Unit 11, probability with categorical and quantitative variables. I got 2 emails yesterday saying that my previous videos, the table was shaking a lot, and I'm really sorry about that. So I have to anchor down my baking soda thing with some sort of weight. So, the engineering capabilities on my end are just getting better and better and more creative. Before I actually get to the note sheet, I just want to do a quick rundown on a separate sheet of paper to try to summarize what we're up to. So lesson 1, we're talking about two-way tables. Another name for two-way tables are categorical tables. Now, categorical means categories, such as male, female, colors like red, blue, yes, no. Like weights and heights, those are more quantitative. So let's say I give you a table. Male, female, Democrat, and Republican. And let me just make up some numbers here. 50, 30, let's go, 65, 70. So here are the totals. So there's 80 males. So we're gonna have 135 females. $100 Republicans and 105. No. Where's my whiteout? 115 Democrats. So right here is the grand total. So how many people do I have in my cells? So we're gonna have 215 total. So I could ask you questions like such. Let's randomly select one person from this table. All right, let's call this A. All right, so what's the probability they're male and Democrat? So this is a male Democrat. Male and Democrat, male Democrats. That's 50 over 215. There's 50 male Dems out of 215 total. If I said probability of a Republican female, that is 70 over 215. These types of questions are called joint probabilities. Joint probabilities, like where they are joining up. So it'll be like an individual cell. Another type of question, I could say the probability of a male or a Democrat. So what's the chance I pull somebody out of here and they're either a male or they're a Democrat? So what you have to do here, this is gonna make an L. So it's gonna be this, these guys. So the 50 right here are male Democrats. The 30 over here, they're not Democrats, but they are males, so these count. The 65, well, these aren't males, but they are Democrats. So the only one that's not a male or a Democrat are those 70 people right there. So what I'm gonna do is I'm gonna add up the 50, the 30, and the 65. So that's going to be 144 out of 215. I could say the probability of a female or Republican. So they either have to be female or they have to be Republican. So 65, 70, and 30. These are either females or Republicans. And that's 65, 70, and 30. So that's going to be 165 over 215. I could say probability of, male or not a Democrat. So if you see stuff like that, not a Democrat would be a Republican in this case. So 50, either a male, so male or not, male or a Republican. This one, this one, this one. 50, 30, 70, sorry. This way you know what I'm adding up. 50, 30, 70 is 150 over 215. I can also ask a question like this. What's the probability that somebody is a male? Well, there's 150, no. There are 80 males out of 215. I could say, what's the probability somebody is a Republican? Well, there are 100 Republicans out of 215. All right. These are called marginal probabilities because it's asking you a question about the margins. These are the margins right here. 80, 135, 115, 100. Here's another type of question. Oh no, out of ink. Let me get a new green pen. There we go. What if I said, what's the probability somebody is a Republican given they're a male? This could also be expressed like this: Republican given male. So given that you're a male, how many males do I have? 80. 80. What's the chance I'm a Republican? 30 out of 80. What if I said probability, what's it, this one? Probability of a female given Democrat. So you always look at the bottom, or the given part. So given you're you have to read it backwards. Given you're a Democrat, how many Democrats do I have? 115. What's the chance you're a female? 65. I could say probability of not being a female given you're a Democrat. So given you're a Democrat, not being a female. So 50 out of 115. And finally, our male, here, is gender independent of party. So is gender independent of party, or basically independent implies no association. It's the same thing if you happen to see it. So does it matter if you're a male or a female? Like, are more males likely to be more Democrats over females? One way we can answer this is by this formula. If the probability of A given B equals the probability of A, then A and B are independent. So let's test this. So what you could do